Welcome to Sravz Technical Series. In today's session, we will continue the discussion of Ticker Plant. In the previous session, we discussed about the Redis time series, and then we have gone through the various commands Redis time series provides us. Also, the aggregation commands Redis time series provides us. And at the end, we mentioned that we are going to use Redis time series to create a ticker plant for us to store uh, a time series for various stock tickers and also the aggregations. Aggregations are like average, min, medium, etc. over a certain time period. And then we implemented that in Golang Websockets here. So today's discussion is around this page. If you are new to Golang, it is recommended to go through these video sessions first, because whatever we have used today for the WebSockets is all based off of these crash course videos. So if you go through this, then you'll get a very good idea about the Golang concepts we use today in the Golang WebSocket. So the Golang WebSocket is developed using Gorilla WebSockets library for the WebSockets, and then Go Redis for the Redis client. Then the flow is WebSockets. We read from the WebSockets and push to Redis streams, and at the same time we also push to Redis time series. And the Redis time series is our ticker plant. I'll quickly go to the this Redis inside. Right now the program is running, so we have a channel here, Redis codes, where we are pushing the real-time codes. We did something similar in C++ too, so this is in Golang now. The C++ portion is discussed here, Boost Beast WebSocket server, Boost Beast WebSockets. It's the same concept, but today we're doing that in Golang WebSockets. So let me go to the high-level data flow once. We have an external vendor who provides us the WebSockets, data over the WebSockets. So we first do an initial handshake. Then we get, after the initial handshake, after the authentication is done, we get a code stream. The code stream will continuously pump codes for the tickers we subscribe to. So we can subscribe up to 50 tickers. So we'll get codes for all those 50 tickers in a continuous stream. On the Gorilla WebSocket side, in this program we're going to discuss today, we have these Go routines. So I'll go from this Go routine first. We have a Go routine which opens a WebSocket connection, and if it fails, it will try every 1 second until it gets the WebSocket connection. Then we have these two Go routines, which will try to get the WebSocket connection from this Go routine. Once they get the WebSocket connection, they'll use that. This Go routine will have a send buffer to which we write data, and then this Go routine will listen on the send buffer. It's a channel. Send buffer is a channel. So it will listen on the send buffer channel and send the information to the WebSocket. So this is to send data to the WebSocket. Once the initial handshake is complete, this Go routine will continuously listen on the code stream. So it is a channel, it is a Go routine. Then the codes it receives at high frequency, it will push them to Redis using Redis CLI, Go Redis library. And then we have another Go routine here which will constantly ping Redis for keeping the connection alive. So these are the Go routines that are involved in Gorilla WebSocket client implementation. So I showed you the channel real-time codes. Right now the codes are being pushed. I'll go to the time series database. So we discussed these Redis commands in the Redis time series video. So I'll run this command once. And there's a lot of data for Ethereum USD. We'll just show that here. Okay, so this is the data, and then I'll switch to logarithmic scale. Okay, so that's the data we get from the WebSocket, and these are the data series we have. and that is all the data we are collecting. Now I'll switch focus to the code base. So the code is uploaded here to WebSocket Go in trainings repo, but I'll go through the code in the VS Code. So we discussed the packages. So packages is a module in which we created a WebSocket client file. Then we set it in packages. We define that in the package jobs package. Then we have a bunch of imports here. Then we imported Redis Timeseries Go, and then Redis Go Redis. We have a bunch of constants here. We'll discuss that when we use these variables. Then we create a request structure. This is the structure that will go on the initial handshake. When we connect to the WebSocket, we have to send the action, subscribe, and the comma separated list of symbols. So this structure holds that initial handshake structure. Then this is the real-time code into which we will save our data. Once we get the code stream from the WebSocket, we'll save that data in this structure. And the real-time code is the structure. We'll send it to Redis. So Redis requires this method defined on the structure so that it will use this method to marshal the structure into JSON. So it is a requirement from Redis Go Redis library. So that's why we create this function. Then these are the structures to save our codes, real-time crypto codes and real-time codes. Crypto codes are a little different, so I had to create another structure for crypto. And these real-time codes will have codes for stocks, futures, index, etc. Now this is our main WebSocket structure, which will contain a context, and then the send buffer we discussed. The buffer is used in one Go routine. We pump the data into this buffer. Another Go routine will read off of this channel and then send it to the WebSocket. And this is a byte array of size, single size. So it will become a blocking call for the other Go routine which is waiting on this channel. And these are a bunch of other variables. We'll discuss those when we use them. So the new WebSocket client will take the client type and the URL, and then it does some processing, right? And then it will create WebSocket client. It creates a new Redis connection and a Redis time series connection, and then it will start the Go routines. So in the data flow diagram, 1, 2, 3, 4, 5. There are 5 Go routines in all. So 1, 2, 3, 4 Go routines are started here. And then we return the connection. Ping Redis will ping the Redis. It will use the Redis client in the connection, and it will constantly ping Redis. And this is the connect Go routine, which is this one. Go routine open WebSocket connection or retry every 1 second if cannot connect. So this is the WebSocket client, takes a pointer, then it does a connect and returns the WebSocket connection. So initially the connection has mutex. We log the mutex because we are doing some we accessing the shared data. If connection is already established, return that connection, or else every 1 second until we open a timer, then we defer the stop. Then every 1 second you try to connect to the WebSocket. If the WebSocket connection is successful, return. If not, try again after 1 second until somebody calls context.done. If somebody can control C, then this loop will be exited. So we'll come out of the loop. So then we'll do the listen on the WebSocket. This go this go routine listens on the WebSocket and pushes the data to the Redis stream. So we listen on the WebSocket, this listen function. Similarly, we have a ticker every 1 millisecond. We listen to the WebSocket because the codes come at a very high frequency. So we listen every 1 second, 1 millisecond. We have ticker. So same concept. If the context is done, we return out of this. Every every 1 millisecond, we'll try to connect to the WebSocket. But since if the connection is already established, we'll get the same WebSocket. So it's not like we are trying to connect every millisecond. And then we send, if it is the initial request, for initial handshake, we get a different type of message. For code stream, if it's code stream, we write to Redis. So we had to do this special handling. If it's the initial request, handle it in a separate way. Don't send it to Redis. If it is not initial request, which is the handshake response, send it to Redis. Write codes to code stream. And this is the write function where we have this go routine function send a message on send buffer. So when we get a payload of any type, we marshal it to JSON, then we open a context, and then we send that data on the send buffer. This is this is one function, and this is another function where this is a go routine. So this one listens on the send buffer. Once it gets some data, it will try to connect to the WebSocket. If it's already established, we will get the same WebSocket. So we're not trying to connect every send, and then we write the message to the WebSocket text. So we do, when we click on a stop on the WebSocket client, we cancel all the context we have opened. So this way all our go routines will know they have to cancel out and they'll close. And close WebSocket, we'll log the mutex, then write the final message to the WebSocket, and then we'll close it. So this is the Redis ping function. It's a go routine. It will ping Redis every ping period. So it's a 1 minute right now. We set it to 1 minute. Every 1 minute it will ping Redis. Then this is a log function. Now this is codes to Redis. Once we get the code from the WebSocket, we do some manipulation of data into the structure. We won't go to this math. You can review that later. So once we get the code into the real-time code structure, we publish to the real-time codes stream using Redis client, which is what we saw here. This is the data, real-time codes. We're getting the data. And also we'll add it to the time series. We'll get the symbol. If it's Bitcoin USD or Ethereum USD, we get that symbol and then take the timestamp and add the price. Right now we're adding only the current price, but we can add any other things to the time series. So we do TS add and add the code. So as an enhancement, we can maybe make this a go routine, then create a buffered channel, and in the buffered channel you put certain data. Only when we get the enough data in that channel, using T multiple add, we can add multiple data points to the time series, like we did in C++. That's an enhancement we can make later. So this is a WebSockets client. We start the WebSocket client, and then we send the initial request when we start the WebSocket client, and then we also create the Redis keys. If you look at the workbench, that query we made, so we create these aggregations and we add these key labels. We create these aggregations, we create these labels, and then we add those labels to these time series. And also we set the retention for each of these. We set the retention to 30 days and create key with option, create key with the option. Then we create rules of aggregation. The rule type is these rules: 1 minute average rules, rule type, average, these averages, those are the rules. And then when we make the WebSocket client connection for the first time, we create these keys, rules, add labels to the tables in the function. So the logic in Go is straightforward. If you want to run the same using Redis CLI commands, we already discussed that in the Redis Timeseries Redis Timeseries session here. So once we do that, in the new client, we set the client parameters, all these parameters. For USD codes, we get these codes for now, just for this demo. And crypto, we get these. Then we start a Go routine, Go cron start async. This is a Go cron in which we run the Redis ping every 1 minute. So we start that Go cron. And then there's the signal handlers we discussed. We wait here. Once we get the signal, we come to this point, and then we stop our crypto client. We stop all our WebSocket clients. We stop the Go cron. We stop the Redis client, and then we exit out. So if I do that for now, everything will be exited. Since we are running in air, it doesn't show these messages, but it exited out. So that's the code base, and this is the data flow diagram. With that, I'll close today's session. If you have any questions, please reach me out either in the YouTube channel or in the discussion tab here. Thank you for watching.